Messy emails and PDFs break naive JSON extraction. I'll use Instructor in Python with Pydantic validation and automatic retries, so you get typed output instead of parser cleanup. This is the workflow you'll know how to run when we're done, which extracts validated JSON from emails and PDFs with automatic retries. I'm Professor Pi, teaching AI engineering and LLM systems with simple Python. Invoices, receipts, and OCR'd PDFs arrive in many formats. A naive JSON extractor often produces strings, missing fields, or broken numbers. That creates manual cleanup and slow downstream pipelines. Instructor in Python helps by asking the model to return structured objects and then validating them with Pydantic, so downstream code can assume types. In practice, this means fewer parser errors and faster finance reconciliation. At a high level, we want predictable objects. We want a vendor name as a string and a total as a number. We want the extractor to retry if the model returns something that doesn't match that contract. Success is when the pipeline produces typed records for hundreds of documents per hour with minimal human checks. The idea is simple. Use Instructor to wrap model responses into a schema defined by Pydantic. If the model output does not fit the schema, Instructor can ask for a corrected response. That gives you a typed object rather than raw text. It is fast to prototype and robust enough for many production flows, especially when you combine light text normalization for PDFs. We will build a tiny pipeline that turns a short email and a couple of PDF-like strings into validated receipts. You will see how retries, normalization, and a final aggregation work together so the extractor is safe to use in finance or analytics. Now we'll convert one short email into a typed object. This snippet turns a short email into validated JSON using Instructor for Python and a Pydantic model. The code first wraps the OpenAI client with instructor.fromOpenAI, so responses can be parsed into structured objects. It defines a simple email model with subject and total fields to express the contract you expect. The variable email txt contains a tiny, readable message that mimics a receipt. The client.chat.completions.create call includes response model email, telling Instructor to coerce the model output into that schema or fail. The result is a typed object with predictable fields you can safely index. The print shows extracted values, confirming schema-aligned parsing. Next, we'll increase realism and add retry behavior for noisy text. This example adds validation pressure and automatic retries using Instructor's response model on a noisier email. It declares an invoice model with a number and a numeric total, so mismatched outputs will be rejected. The messy email variable intentionally mixes casing and wording to mimic real inbox chaos. The client.chat.completions create call sets response model equals invoice and max retries 2, allowing Instructor to ask the model again if the first parse fails validation. The final object res2 is guaranteed to fit the schema or raise. Increasing max retries tends to improve robustness while adding latency and cost. Decreasing it risks failures, but is cheaper. The printed total confirms a validated numeric extraction. Now, we'll batch multiple documents and pick the largest expense. This code batches 2 documents, extracts structured fields with Instructor, and selects the largest expense. It introduces an expense model for the vendor name and total, so each extraction returns a consistent, typed result. The list docs mixes our earlier email with a compact PDF-like string. A list comprehension calls client.chat chat.completions.create for each text with response model equals expense, ensuring validated objects across the batch. The variable outs holds the parsed results, and top uses max to pick the highest total. This provides a quick triage for finance workflows. The printed vendor and amount confirm which document carries the largest validated charge. Next, we'll clean noisy PDF text so extra retries become rare. This snippet cleans PDF-like artifacts and then extracts with Instructor to improve parse stability. The function normalize removes hyphenated line breaks and collapses whitespace so downstream prompts read cleanly. The variable PDF text simulates OCR-style formatting noise. After normalization, the call to client.chat.completions.create uses response model equals expense to enforce a consistent vendor and total, while temperature equals 0 reduces randomness and typically avoids extra retries. More aggressive normalization can lower token usage and latency, but risks deleting context. Looser normalization preserves detail, yet may increase retries. The printed character reduction shows how much text you trimmed, explaining potential cost and accuracy changes. Finally, we'll combine everything for a tiny end-to-end baseline and sum totals. This example assembles a tiny baseline that handles both emails and PDFs with Instructor and Pydantic. It defines a receipt model with vendor, total, and a kind tag so downstream logic can branch safely. The list docs2 mixes the earlier email with a short PDF-style string. The function extract normalizes text for PDFs using normalize and then calls client.chat.completions.create with response model equals receipt and max retries equals 3 for resilience. A simple list comprehension collects validated objects, and total USD aggregates the amounts for quick ledger updates. The final sum demonstrates end-to-end structured extraction that resists format quirks and silent schema drift. To map this toy flow to a real system, you would run normalization as a pre-processing step, parallelize calls over a worker pool, and write the typed records to a database where the schema matches your Pydantic models. That makes downstream queries and audits straightforward. Recap. It is a pattern for extracting typed records from messy text using Instructor in Python plus Pydantic validation. Use it when you need predictable fields from emails, receipts, or OCR output, and when silent schema drift is a risk. Caveat. Retries add latency and cost, so tune retry limits and normalization carefully. Next step. Scale the pipeline by running the extractor across a larger corpus, and add a timing and accuracy check so you can tune max retries and normalization aggressiveness. If short, practical AI engineering helps, subscribe and watch the AI engineering videos.